Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Mishkabur Rahman and we are from Group Pacman, and I'll be describing our network and system administration project. So this will be our presentation. So our project is deploying a multi-tier web server architecture on Google Cloud Platform. So why do we choose Google Cloud Platform as our cloud platform? So one of the reasons we chose Google GCP is because Google for a free trial gives $300, and also the time period is 1 year. So compared to our rivals DigitalOcean, AWS, or Azure, Microsoft Azure, so the time is a lot because DigitalOcean gives like $100 credit for 3 months. So it's a lot better to deploy an architecture in Google Cloud Platform and tinker with it so that we can modify it in future and do some other works. So let's move on to the system architecture. So this is the system architecture of our whole project. So as you can see, we deployed this system architecture on Google Cloud Platform. In our architecture, we have 4 VM instances. So the first VM instances or server. So the first server will be the load balancer server. So the load balancer server is and then we have 2 web servers. Both web servers are running the Apache web server, and both servers are like mirror of each other, and both of these servers are connected to the database server that is running MariaDB, and all of the three servers, the database server and the web server 1 and 2, all 3 servers are running LAMP stack. So LAMP stack stands for Linux, Apache, PHP, MySQL, and PHP. But instead we used MariaDB. MariaDB is a fork of MySQL database. And for the load balancer server, we only have the pound load balancer service installed on CentOS. For web server 1 and 2 and the database server, we use the Ubuntu operating system. And for the load balancer, we use the pound load balancer. We'll go into details later. And every VM instances under one project in Google Cloud Platform. As you can see, this was my first project. They have for every project, all the VM instances have a global firewall. So as you can see, this is Google VM instances global firewall. So the internet will come through the global firewall and to all the computers and servers. Okay, let's move on to the system architecture. So as I have already described, so we have 4 VM instances in our system architecture, which are acting like as servers, and the pound load balancer can distribute L7 and HTTP load balance between web server 1 and 2, as I have already mentioned that they are both mirror servers. Okay, moving on. So this is our GCP or Google Cloud Platform infrastructure. Let me show you the demo. If we go to the compute engine, so these are all the VM instances or server that we have for this project. So balancer new, so this is the load balancer of our project. So this balancer server will distribute the load balance between web server 1 and web server 2, and these two web server 1 and 2, they are connected to the database server. We can connect to all these 4 VM instances or VM servers through Secure Shell SSH connection. We'll demonstrate that later in our demo. So if we click on each server, it will show the permissions and the status of each server. So these are the CPU status, the network that has been utilized by the server, and we can show this for each server. So it can show both incoming connections and outgoing connections. So this is just a monitoring of each web server. Moving on. So web server 1 and 2. So this is our web server 1 and this is our web server 2. So our web servers are running Ubuntu 18.04 VM instances. Okay, let me just open web server 1 and 2. So I'm connecting to both web server 1 and 2 by SSH connection. It will take some time. In the meantime, I'll describe the project. So both our web server 1 and 2 are running Ubuntu 18.04 VM instances, and each web server 1 and 2 acts as a mirror, and both web server 1 and 2 have LAMP stack installed. Server 2 has self-signed SSL certificate for installed for HTTP request, but since this is a self-signed SSL certificate, so the browser will show an error, but still the connection between the web server and the user is secure. But in Google Chrome, it will show that there is a security error. So that's why we only install SSL certificate on Webserver 2. But for this project, we'll mainly work with HTTP instead of HTTPS for simplification. Okay, so the primary use of our web server 1 and 2 is running Apache web server, and it also stores the necessary web pages to display to the user who are requesting the web pages, and they are connected to the database server. And both web server 1 and 2 are running on Intel Haswell CPU with 3.75 GB RAM and 15 GB of hard disk. Okay, so both my web server 1 and 2 are connected. Okay, let me show you the details of web server 1 and 2. Oops. Okay, so as you can see, web server 1 has the Intel Haswell platform, and these are all the important data. So these are network details, the primary internal IP and also the external IP that will be discussed later. Okay, so as I mentioned, both have LAMP stack installed. So let's check out the VM web servers. So as you can see, both have almost 15 gigabytes of memory, and these are the internal IPs. Okay, let's do sudo systemctl status Apache 2. As you can see, Apache web server is running on web server 1, and also let's see sudo status Apache 2. Sorry. Okay, both servers are running Apache 2, as demonstrated here. If we change to cd infra www/html, let's do ls. As you can see, in our directory var/www/html, we have the main index HTML of Apache server. But in our project, I changed the main landing page of index HTML to login.php. So every time when someone accesses our web server, they will land directly onto the login.php web page. Okay, same for web server 2. Change to for www/html. Next we do ls. We can see that both have the info.php, login.php, then we have dbconnect.php and authenticate login.php and style CSS. So these are the 4 files that will be necessary to show our users the actual website. Also, let's see the status of other MariaDB. MariaDB. As you can see, MariaDB is running on Webserver 2. Also, MariaDB is running on Google Server 1, and we are also running PHPMyAdmin in both web servers. So the external IP address for web server 1 and 2 are these two, the external IP address. We can easily access with our PHPMyAdmin. So let me open it in a new file. So it is refusing to connect because it requested an HTTPS connection. So if we do this and then go to PHPMyAdmin, we can see that it is can access the PHPMyAdmin, and we can log in. Okay, so we can log in, and as you can see, there is so in our database server. In our database server, we have this mashlog demo. This database is actually saving all the information for the database server and for the web server 1 and 2 to access the actual data. But from the PHPMyAdmin, as you can see, there is no mashlog database here. So our servers are actually accessing the database from the database server, which we will demonstrate later. And let's go to server 2. As you can see, the server 2 can handle HTTPS requests, but it shows some privacy error. So because it's a self-signed certificate, but we can proceed to it anyway. And this shows the Ubuntu default landing pages. Let's go to the link. HTTPS. And we'll also go to the PHPMyAdmin. Okay, so this is the PHPMyAdmin panel of Webserver 2, and as you can see, it is running MariaDB like Webserver 1, and it doesn't have the mashlog demo database here for our web server to actually request. Okay, moving on. Okay, so these were our database server, web server 1 and 2. Now let's see now we'll proceed to web server 1 and 2. So web server 1 is also running on Intel Haswell platform. So the database server. Let me connect to the database server. So the database server is also running on Ubuntu 18.04 VM instance, and like the web server, it also has one virtual CPU with 3.75 gigabytes of RAM and 10 gigabytes of hard disk, and it also have a LAMP stack installed, and it also have the PHPMyAdmin installed. And the primary use of this server is the running MariaDB. MariaDB is a fork of MySQL database system. Okay, so I'm connecting to the database server now via SSH. Okay. this is my database server, and like web server 1 and 2, it also have LAMP stack. But in this web server, we only have the database that the web server 1 and 2 will send request so that you can access the database info from this server. So let's see if it's running the MariaDB database. So as we can see that MariaDB is actually running in the database, and let's go to the PHPMyAdmin panel. So it is also requesting an HTTP, and that's why it's not working. So if we go HTTP and then go PHPMyAdmin, we can access the MyAdmin page. PHPMyAdmin is very useful to operate on databases. Okay, we have logged into the database server, and as you can see, the database server has this database called mashlog demo, and this database server, so this is our database, and we can actually see user login this table. So ignore all structure. So this is our database structure. This is our tables. So as you can see, this is our actual database there, and this database will be accessed by web server 1 and 2. Okay. So if you see here, there is just only one username and password for this database, that is username mashlog, and password @123, that is the password. So this is the only database that can be accessed by web server 1 and 2, and this is running on a separate database server. As you can see, 35.196.95.184, and the database server also has the same external IP address. Okay, so moving on to the load balancing server. So this is our load balancer server. So the load balancer server is usually running on CentOS 7. The reason we are running CentOS 7 instead of Ubuntu is because the pound load balancer service is not being deployed for the latest Ubuntu 18.04, and it has been removed from the Ubuntu repository. So that's why we choose to go with CentOS for the pound load balancing server. So it is also running on Intel Haswell platform as well. Okay, so let me connect to the load balancer server via SSH. Okay, so this is the information of our load balancer server. Our server is running on CentOS 7, and like the database server, it also has one virtual CPU with 3.75 GB of RAM and 10 GB of hard disk. This server doesn't have any LAMP stack installed. Rather, it only has the pound load balancer service installed, and all the incoming traffic that will be connected from the internet will be handled by this load balancer server. So people will actually request to this server's IP address instead of web server 1 and 2, and the incoming web traffic from the users will be distributed. The loads or the requests will be distributed between web server 1 and 2. One of the some benefits of pound load balancer server is that pound can support virtual host, and it is also configurable, and pound can also reject incorrect requests, and it can also detect the backend failure and can balance load accordingly. Let's say we have a web server 1 or web server 2 down, then we can then pound can automatically detect that one of the web servers down, and it can automatically load the balance. So okay, so this is our load balancer server. So let's say sudo systemctl status pound. So as you can see, our pound load balancer server is running accordingly. Okay, so let's go to a load balancer server. Okay, so this will be our load balancer server. If we go to the configuration page of Pound, okay, so this is the configuration file for Pound. As you can see, the Pound service is listening to HTTP requests from all addresses, as the address is 000 for both HTTP and HTTPS. So it's listening to all ports and from all connections. And when the Pound service gets any connection, gets any request, then it sends the request to the backend service. As you can see, in the backend, we have one service and we also have another service. So this is service 1, and then we have service 2. And if you look at the address, these addresses are very similar because these are the address for server 1 and server 2. So let's go to the, as you can see in the VM Cloud Engine, so 35.237.8181 is the external IP address for web server 1. And 35.237.127.90 is the backend, is the address for web server 2. As you can see, they both are the same. So what Pound does is when it gets an incoming connection to its original connection 35.237.157.39, it redirects the connection between server 1 and server 2, and it can also detect if one of the server is down. So, and it can also redirect the server load accordingly. And with Pound Balancer, we can also have an emergency option. Let's say in some cases both servers are down, then it can reroute the user to another web service. But in our case, we didn't do that. And also with Pound, we can have some priority set to one of the backend servers. Let's say if we wanted to give the server 1 a priority, we can just easily write something, let's say priority 6. If the priority is above 5, then that server will get the priority for when it comes to handling the request. But in our case, we'll just evenly distribute the request. 480. Okay, so this was our load balancer server. Moving on. Okay, so the networking of our VM instances. So our web server 2 has a static IP address, but all the other web servers and database servers doesn't have static IP address. Instead, they have ephemeral IP address. Web server 1, load balancer server, and database server has ephemeral IP address. Instances with ephemeral IP addresses loses their IP address when they're shut down, and when they're restarted, they are given a new IP address. Since we're using GCP's trial version, Google allows only one static IP per project, and also all the VM instances have their own internal server IP address, which is 10.142.0, and which is on the 20 subnet 20. As let me show in the Google Cloud Platform. If I go to VPC networks, so this is the networking of VM instances or server. So as you can see, web server 2 has a static IP address, but web server 1 database server and the balancer server doesn't have a static IP address. And in the demo, when we're going to show the demo, I will shut down web server 2 instead of web server 2 instead of web server 1, because if I shut down web server 1, it will give the web server a new external IP address, and then I will have to manually edit manually edit the configuration files for database server, load balancer server as well. So that's why I'll only shut down web server 1 to demonstrate the demo. Okay, so this so as you can see, this is the external address, and also each web server has their own internal address. Like I mentioned here, they have their own internal primary IP, which we can access by going to their respective pages. As you can see, the network interfaces, they have, like for our web server 2, their internal IP address is 10.142.0.4, and this is the static IP address. Okay, moving on to the next one. Okay, this one is already done. Okay, so this is the global firewall rules for VM instances. We can access the global firewall rules from VPC firewall rules. So all the VM instances, or all the virtual machine or servers, all these 4 have this global firewall that is already been done by Google, and I have added the telnet rule to allow the web server 1 and 2 to connect to the database server, to access the database server. That's about it. And I have already demonstrated the PHPMyAdmin part. And okay, now let's okay, so this was our database server, and our database server has the mashlog demo saved on the database server that is running MariaDB, and this DB contains username and password, and web server 1 and 2 request their SQL query to this server. So how it works? Okay, now we will show the demo. Okay, we'll go to the compute engine. So the user will request to the balancer new to balancer server instead of web server 1 and 2. Okay, let's request to the web balancer server. As you can see, it is showing a privacy error, so we will not. Instead, we are going to use the HTTP, and then we're going to look at. As you can see, I have requested to 35.237.157.39. This is our balancer server, and our balancer server has redirected me to web server 2. And if I can show you web server 2, so this is my web server 2. Sorry, if I go to my balancer server, if I go to my load balancer server, we can check that there is no Apache server in the load balancer server. Systemctl status HTTPD. Sorry. Unit HTTP service could not be found. So this shows that our balancer server does not have any Apache web server. So this is coming from web server 2. So if we refresh the web server, we'll see that suddenly the web server changed from web server 1 to web 2 to web server 1, and that's because we are requesting the web pages from our balancing server. So the balancing server so our balancing server just distributes the traffic evenly, or as it finds it necessary to redirect from web server 1 and 2. So if we refresh, we can see that sometimes we go to web server 1 and sometimes we are redirected to web server 2. And let's say we'll disable web server 2. So let's go to web server to server 2 sudo systemctl stop apache 2. So our web server is on our Apache server on web server 2 is now stopped. Systemctl that so as we can see, the web server is not active. So let's refresh our balancer server. Let's see if we get the web server 2. As you can see, we are refreshing so many times, but all the time we are being redirected to our web server 1 instead of web server 2, and that's because our pound load balancing server our pound load balancer server already knows that our web server 2 is down. That's why it is redirecting the loads and requests to only web server 1. Okay, now let's enable the web server 2. Web server 2. Okay, so our web server 2 is now up and running. So let's see if pound shows web server. So if our pound load balancer gives us the web server 2. Okay, so now you can see that our pound load balancer found that web server 2 was up and running, so it distributed the load request to web server 2. Now if we right now I just refreshed and it showed me web server 1, and okay, another one, web server 1. So I can now so it is now showing web server 2, and this is all being done by the pound load balancer. So let's see what is done. So our password was mashlog and password 123. So let's say if we do the correct one, mashlog word at 123. If we submit, login credentials verified. So as you can see, this the credentials are verified from the MariaDB server, MariaDB database server that actually has the web server. So let's say this. So we did it in web server 1, and let's do the same thing in web server 2. Sorry. Okay, so this time web server 1 is now running. So if we put the right one, mashlog word at 123 login, so it is showing login credentials verified. But if we submit a wrong query, let's refresh. Okay. That's a new. Oops. Okay. Let's say we put a wrong username and password, and it will show login credentials invalid. So this is our project. So the people will request. So in short, people will request for the page to the load balancer server. So as you can see in the demo, I have requested for for my required pages for server 1 and 2 to the load balancer server, and the load balancer server redirected the traffic that came to the load balancer server to web server 1 and web server 2. And people type the username. If we go to this URL is live, so you can easily access this URL and check the demo by yourself. And if the so the load balancer redirects the load request to web server 1 and 2, and if we send the query will be sent to the database server, and if the credential is valid, then it will show the credential is valid. If the credential is not valid, then it will show the credential is invalid, as I've already demonstrated. And also I have showed that if one of the servers is down with let's say I down web server 1, I down the Apache web server on web server 2, and our bound load balancer was directing all our load or request to web server 1. Okay, so this was our project. Thank you very much. Assalamu alaikum wa rahmatullahi wa barakatuh.